Welcome back, guys, to another video about chemical reactions. In this video, we are going to cover decomposition reactions. Now, think about decomposition as the opposite of synthesis, where synthesis helps us bring two reactants or more together into one final product. Composition starts with one reactant that will split up into multiple products. So it doesn't have to be two. Usually it is two, but it could be more. So let's look at the definition that we have on screen. A single compound that is broken into two or more elements or new compounds. So basically the idea here is that, again, we start with a compound, for example, aluminum oxide, and after the reaction has taken place, the elements, and it doesn't have to always be split into elements, it could actually be split into compounds, will be the result, right? The products. So the individual components of the original compound will be split up. Now, and when I say split up, I don't just mean like, oh, you cut down or you break apart your sample. No. I'm talking about the actual chemical reaction and the idea that we are unbonding the structure itself, okay? So we're not just breaking down our samples. Now, when it comes to decomposition, many times we add catalyst. So let me backtrack a little. If we talk about decomposition, a lot of times people think about like the human body decomposing or food, going bad. So yes, you can think about it that way because things are being broken down into like smaller components. But in reality, when it comes to a chemical reaction, a lot of times we have to do something to speed up that process. And that's where catalysts come into play. And catalyst is just one of the many ways that we can speed up the chemical reaction from taking place. And you might be wondering, so why do we need a catalyst? Yeah, okay, you just said that you're speeding up. Yeah, we're speeding up the process because time is limited, right? And also because a lot of the results that we want to obtain might potentially take hours, days, months, that we need that result right there and then. And that's when the catalyst comes into play. So let's look at the definition. It is a compound that is added to a system to speed up the rate of a chemical reaction. When we see the word system, we're talking about those components that you are specifically focusing on. Okay, so we'll look at that in the lab video section of this lesson. Now, something very, very important to note is that when we write the balanced chemical equation, catalysts are not included because, again, they're only used to speed up the process of decomposition and not necessarily to help our compounds bond, okay? So let's look at the laboratory example we will see in just a moment. We are going to start with hydrogen peroxide. You guys might very likely have used it at some point for maybe when you got a cut or you were trying to clean something. It's that liquid that comes in the brown bottle that a lot of safety kits or first aid kits have in them. That's what I'm talking about here, and that's what we're going to use. We are going to look at two different catalysts, and the reason for having two catalysts in the video lab section is because I want you guys to be able to see what different catalysts would do, how they would look like, how they can create different chemical reactions, and specifically, since catalysts are used to speed up, which catalyst is better than the other to speed up. You'll see that one of the two starts acting immediately. The other one kind of takes a little bit longer, but at the end result gives you a really good reaction. So anyway, so when we talk about this lab example, make sure that if you are working through your laboratory handout, you look at that here. We are going to start with hydrogen peroxide, which is H2O2, and is going to be broken down into water, H2O, and oxygen gas. Now, of course, like how we have been doing for the last couple of lessons, we need to make sure that we balance our chemical reactions. So right here, hopefully we're getting to the point that we can start doing balancing our heads. So I'm not going to go in depth, but here our coefficient should be 2. which would then tell us that there are 4 hydrogens, because 2 times 2 is 4. And on the product side, we would also write a 2, so a total of 4 hydrogens as well. And then, of course, just like in algebra, we distribute. So 2 times 2, that's a total of 4 oxygens on the reactant side, right? 4 oxygens. And on the product side, we have 2 oxygens here and another 2 oxygens there for a grand total of 4 oxygens on the product side. So let's take a moment and let's look at the examples in the lab.
All right, guys, so in this part of the video, we are going to look at 2 examples of a decomposition reaction. So what I'm going to do is I'm going to add into each of these, both in these test tubes, some hydrogen peroxide. So H2O2 would be your formula. And in one of them, I'm going to add potassium iodide. In the other, I will add iron 3 chloride. And the goal of this particular example will be for us to see that the hydrogen peroxide releases all of the oxygen that it has in the bonds, okay? Now, the reason I'm going to add these 2 is not to actually bond the hydrogen peroxide to that, because my goal is to split, right, to separate my H2O2 into their individual components. So what the reason for these is a catalyst, and that was already discussed in the video, right? So a catalyst is just meant to help us speed up the process of the reaction itself. So what I'm going to do is exactly that. That is the purpose of these 2. All right, and it's just, you're going to see the difference in the reaction, okay? So what I'm going to do here is, and I'm not taking measurements because really it's just, we're just observing. If you look at the handout that you were given for today, there's no place in there for you to measure anything. So it's just all qualitative. So I'm using a pipette and I'm transferring some of my hydrogen peroxide into the test tube. And I'm not going to do too much because otherwise you guys won't be able to see it. But I'm going to do roughly the same quantity on both. So it's taking a little while, but that is okay. And then to prove that I am indeed decomposing the hydrogen peroxide, I want to collect as much of the oxygen as possible from the reaction. And then to prove that it is oxygen, the one that's getting released, we're going to light up a toothpick, okay, with that oxygen. So I'm going to close my hydrogen peroxide. It's always good practice to always have your bottles closed. And then I'm going to do my first reaction. So let's start with this one. And I just realized I don't actually have my scopula. All right, so I'm gonna pour some of the potassium iodide into my hydrogen peroxide, and we're going to note what, look guys, this is not what you're supposed to do. You're supposed to actually have your tools. All right, so the first thing you should be able to see is that a reaction is taking place. A couple of reasons. We saw a change in color, and we also see gas being formed. Now that gas, like I said, is the oxygen that is being released. So that is what is happening here. So I'm gonna let it sit for a little while because I don't want, I'm gonna put the cork on top to try and trap as much oxygen as I can, but I also don't want it to just pop off. So I'm just gonna place it here and leave it there for just a moment. In the meantime, what I will do is that I'm going to start the second reaction, which this is iron 3 chloride. I'm going to take some of it, just pour it here. Again, we know that there's a reaction because we saw a change in color. And this one's taking a little bit longer, but if you guys can see here, we also are getting some reaction. Just a little bit. You guys, hopefully you guys can see the bubbles there. And starting to speed up a little. All right, so again, just like the other reaction, I'm gonna let it sit for a little while. And then I'm gonna get my cork and I will close it. Okay, so this one's still going pretty strong. Can you guys see that? All right, so I'm gonna leave it here. And then, like I said, what I'm gonna do is I'm gonna light this on fire. I'm gonna use my lighter. I'm gonna blow it out, and I'm gonna stick this very carefully inside. And hopefully if I did do this right, it'll catch back on fire, so it will reignite. So I think we're ready for the first sample. Okay, so ideally you would want to do this with a partner because it's kind of hard to try and do all of this at the same time. All right, so it's on fire. So you notice every time I blow it out, goes in, catches back on fire. You guys see that, hopefully. Like I'm blowing it out completely, going in, catches back on fire. And just to prove to you, it's not that it's just turning on, right? Because look, right there, it's not catching fire, but as soon as it goes in, it catches fire. And I don't think you guys can hear it, but there is like a little popping sound. It's like pop, pop. So that's another indicator, right? What we previously learned, that a reaction is indeed taking place, right? Light or sound can come off. So let's try the other sample that we have here. And this would be so much easier if I had a partner, but it's okay. So, try and hear for the little popping sound. I really don't think you guys can hear it, but it's there. So again, see, it's off. Nothing's happening. Put it in. That's back on. So anyway, that little popping sound again is just letting us know that there is oxygen is being released. And of course, if you didn't believe me, you can still see regardless the reaction taking place. Look, this one's speeding up. Remember at the beginning it was really slow, and now it's speeding up. All right, guys, so these two, oh, and you guys can't obviously touch it, but if you were to touch it, this is actually getting warm. So it's also changing temperature, right? So an increasing temperature also is another indicator of a chemical reaction. It's just like a little bit warm, not really a lot, but it's definitely not the temperature of the hydrogen peroxide that we started with. Like, this is completely cold. All right, guys, so these are two examples of our decomposition reactions. Hopefully you guys enjoyed.